Okay, so let's start talking about what do you mean it's not 100%. This is a lecture going over how to calculate percent yield. The quote we have, I knew I could control one thing, and that is my time and my hours and my effort and my efficiency. So, this whole lecture is going to be about efficiency. We're talking about percent yield. The learning goals, students will understand some of the factors that restrict experimental yield. So we're going to look at what limits how much we can actually get produced. We talked about limiting reactants. We're going to talk about a few other things that kind of hinder how much we can produce. Number two, students will be able to calculate the percent yield. So we actually want to be able to answer percent yield questions. So let's dive right in. What we should already know. Reactions are limited to the amount of reactants. This is where we get into limiting reactants. How much we have depends on how much we can produce. That's the whole law of conservation of mass. We can't produce any more than what we have. And the limiting reactant, it limits it. Running out of one reactant halts the reaction. So when we use up all of the limiting reaction's done and it stops. And then all reactants must be present for the reaction to occur. So once we run out of one, the reaction stops. We can't do anything. Now, looking in the lab, what we did there are times when you won't get as much product as the equation and math tell you that you should. Very few chemical reactions are 100% complete. So, rule of thumb is normally we're not going to get 100%. We get around 98, 99, we're doing really, really good. But not all reactions are going to be 100%. So, nobody's really perfect, and that's the whole we're not going to get 100% thing. Reactions almost never react 100% of their possible yield, so we're not going to get 100% of the product. A lot of reasons go in on that. Here's a good example. Let's see, we have the reactants and they're bonding together and everything else, and well, they just don't get on the same side. For a reaction actually to happen, the atoms actually have to touch each other. They have to come close to each other for a reaction to happen. And if that doesn't happen, then guess what? You're not going to produce anything. There's not going to be a product, and you're not going to get 100%. Okay, other factors, the reactions depend on a lot of different things. Temperature. Okay, temperature has to deal with it's increasing the rate of collision between atoms. We'll talk about temperature and kinetic energy a little more later on in a couple different units. But the one thing that we need to understand is that temperature really it's kind of related to the kinetic energy. So how much it's moving, and so the more it moves, we increase the rate that it's moving. It'll increase the collisions. Looking at pressure and volume. Anytime that we change the pressure or volume, it changes the space. And in a confined space, it makes more collisions and the right molecules colliding with each other, and they're more likely to hit each other if they're in a tinier area. A catalyst. Catalysts are great to use, and they can increase how much we produce. A catalyst is just something that speeds up the reaction. It helps the reaction along. It doesn't really have anything to do with it, but it helps it and speeds it up. A medium, what the reactions are in. Is it an aqueous solution? Is it a gaseous solution? So, whatever the medium is, that can affect the reaction. Number of reactants and concentration. So if we're really concentrated, or is it not so concentrated, it's weak. And then lastly, the number of products in the concentration. So the products can block formation of new products. So basically, a product gets in the way and it's not allowing those other particles, the other reactants that kind of get in there to actually bump into each other and actually react. So let's jump into an example. Example A1, it says that doctors are in desperate need of 2-acetobenzoic acid, and a chemist has 2.5 kilograms of salicylic acid and 1 kilogram of acetic anhydride. What can be done to maximize the yield of the reaction? So here's a reaction, a lot of big words and everything else, but basically, what can you do to increase the products of the reaction? Well, we can talk about a lot of those things, or what we just talked about. We can increase the temperature. Okay, if we increase the temperature, these guys right here will collide more, and so therefore it'll produce closer to 100%. We can decrease the volume, so make the space smaller. They bump into each other more. Increase the concentration, um, and dissolve it in a solution so that they're actually colliding a lot easier, and they're more concentrated, so they're more likely to hit each other. And use a catalyst to speed it up. And then make sure that we have a good method of removing the product after the reaction has occurred. So we got to be able to get it out of solution or actually recover the product. So those are just some things that the doctors can do to speed up the reaction, actually get closer to 100% and be more efficient. Looking at our next reaction, our next example, it says explain the role of sulfuric acid in the reaction below. Well, we're looking at this, and sulfuric acid, since it's over the arrow, we know that it is a catalyst. Okay, and this is basically what's going on in our stomachs. And we see that we have our hydrochloric acid right here, and we're looking at the reaction that's taking place, and we can see that that sulfuric acid is going to act as a catalyst. Really, what is actually happening is the sulfuric acid is a catalyst that removes that hydroxide. So it moves this hydroxide right here, and from the molecule, and forms a positive for that carbon, and this carbon attracts the chlorine to stabilize itself and allows the hydronium ion to reform with the sulfate to bring back the sulfuric acid. That's what's happening. What we really need to know and focus on is that, hey, this guy's above the arrow. It's a catalyst. It's going to help speed up that reaction.